Okay, so quadratic equations, review of factoring. So today we're just going to look at difference of squares, common factors, and then simple trinomials. So the easier stuff. And so we're just only doing half of this lesson. So 379, yep. 377 today. Yeah, we're doing the front and back basically of this page, okay? So Joe correctly writes the quadratic. So we're looking at when the a value here is 1. Okay, so that's going to be, do you remember what we call that? I just said it. What type of trinomial when the a is 1? It is a quadratic because x squared, but it's a simple trinomial. Simple. Okay, so Joe correctly writes the quadratic expression in factored form using the method of inspection. So what did she do? So when we have a simple trinomial, we want it to get in factored form. We want two numbers that multiply to which one? Do you remember this? So when we want to factor C, which is 12. So the last term. When we have a simple trinomial, two numbers that multiply to the last, and then two numbers that add to the middle. There you go. So in this case, we want two numbers that multiply to 12, add to -8. We have to keep the sign with it. So we made a tree, right? A factor tree for which number? 12, the product one. So we take 12 and we say, okay, how can we write 12 as a product of two numbers? We start at 1, 3 times 4. So 1 times 12, 2 times 6, and 3 times 4. Now we also think about the signs. When we are multiplying to a positive and adding to a negative. Adding to a negative. So that's where the chart comes in. So do you remember when we multiply or divide? So our sign, and it could be times our sign or divide by our sign. I wrote sign wrong. Equals another sign. Like this. Let's write this again. Okay, so we have a box like this. So if we had a positive times a positive, what would that equal? Two positives, and you multiply them together. Positive. Okay. Positive and a negative. Remember, good guy dies. Remember that story? Okay, so the first one's good guy, bad guy, and then whether he lives or dies. So if the good guy lives, that's good. The good guy dies, that's bad. It's equal to a negative. If a bad guy lives, it's equal to a negative. That's bad. And if the bad guy dies, that's good, right? So if we want to multiply, to a positive, there's two ways. How do we multiply to a positive? Two negatives or two positives. So if that's the case, if it's either two negatives or two positives, what in this case we want to add to a negative. So it's going to be two positives or two negatives. If it's going to, our numbers have to add to a negative. It has to be both negatives. So -1 times -12 would give you positive 12. -2 plus or times -6 is positive 12, and -3 and -4 would multiply to positive 12. So which ones add to -8? -2 and -6. Those are our numbers. -2, -6, -2, -6. So factoring now, we just add two sets of brackets. There we go. Our x squared just becomes x, and then we just put in our two numbers, -2, -6. Now it's factored. And so this relates to, remembering quadratic equations, this would be general form, the first one, right? That guy's general. This is what we call factored form. So that would be our zeros. Okay? So it is going to actually come into, all this factoring is going to come into use this unit, all that factoring we learned before. We'll come back to it after. Okay, Okay, so we're going to factor these guys. So this first one, we want two numbers that multiply to who? 30 and add to 13. So who are we going to make a product tree for? 30. So starting at 1. 1 times 30. 2 times 15. 3 times 30 divided by 3. So grab your calculators. 10. Does 4 go into 30? No, how could you check? You grab your calculator and try. 30 divided by 4. Okay, where'd it go? I thought I opened you. 7.5. So we want an integer, so that means it doesn't go in fully. 5 does. 5 times 6. And now we're back where we started, so we're done. Okay, so we're multiplying to a positive. So what are the two ways we can multiply to a positive? Either two positives or two negatives. So in this case, if we're going to add to a positive, which situation do we have? Has to be two positives. Okay, so which one's added to 13? 3 and 10. Our numbers are 3 and 10. So how would we write this now? X plus 3 times x plus 10. Because we want to add to 13. Right? Add to the middle number. Yeah. Okay, oh, the nice thing is now we're set up nicely. Because again, this time we want to multiply to negative 30. So very similar products. And add to negative 13. So how can we multiply to a negative? Negative and a positive. This time a negative and a positive. So what are all the ways we can make a negative and a positive with these numbers? Negative 1, positive 30, or negative 30 and positive 1. What else? Negative 2, positive 15, or 2 and negative 15. Negative 3 and 10, 3 and negative 10, and 5, or negative 5 and 6, and 5 and negative 6. So which one of these adds to negative 13? Oh, that would be 3 and negative 10 would add to negative 7. Negative 2 and positive 15 would add to pos. So if we want our sum to be negative, we want the negative to be the larger number. So 2 and negative 15 would add to negative 13. So now what would it become? So 2 and negative 15. X plus 2, x minus 15. All right. You want to try the next one? This is the new unit, just a review of factoring. Lesson 1 of the new unit. Practice exam is going to be Monday. Tuesday will be unit exam. Okay, so looking at our numbers, it has to be both negative. Ooh, I want feedback. Both negative. So you're going to have, it could either be negative 1, negative 30. Right? Negative 2, negative 15. Negative 3, negative 10, or negative 5, negative 6. Why do they have to both be negative? Multiply to a positive, but add to a negative. So which numbers? Negative 5, negative 6, so it becomes x minus 5, x minus 6. Okay, so that's review of simple trinomials. Next, I explain how to factor the quadratic expression x squared minus 16 using the method of inspection. So in this case, we would want to multiply to, what's our last term? Negative 16. What's our middle term? 0. Add to 0. What would they have to, what? So negative 16, we know that one's going to be positive, one's negative. Whenever you have a negative product. Yeah, Tim? Negative 4 and 4. Because they have to cancel, they have to be the same number, opposite signs. So what does that become? X minus 4x plus 4. Do you remember these? We called them difference of squares. Right? Remember, what's the square root of x squared? X. What's the square root of 16? 4. And that's where x minus 4x plus 4. And so, say 3 other values of c that could be, okay, so what else could c be so it becomes a difference of squares? What are some numbers it could be? Any squared number. So give me an example. 36 could work. What's another perfect square? 49, 81, right? So it has to be a perfect square. Okay, so explain why this method is referred to factoring difference of squares. Because they have to be perfect squares. And when we're talking about we're talking about the c value. And the middle term, obviously, 0. So they're going to be the same number. Okay, turn the page over. Let's practice difference of squares. So let's do this the fast way. So notice, what makes something a difference of squares? Yeah? 2 terms. So this is a different 2 terms. Why else? What else to make it a difference? The middle is 0, so there's no middle term, so that's why there's 2 terms. What do we call this last number? What did it have to be? Perfect square. So it has to be perfect squares. And the middle sign, the sign of the middle in between, is always negative. Okay, then it's a difference of squares. So, and then it's really easy. Because what's the square root of 49? 7. So what does it become? X minus 7x plus 7. Does it matter the order in which you put those two? No. The next one, what would it become? So square root of 64 is 8, so we get, it's a t instead, t minus 8 and t plus 8. Okay, how about this guy? Square root of 25x squared, 5x, so it becomes 5x. Square root of 1, 1, so 5x minus 1, 5x plus 1. And how about the last one? 10x minus 9 times 10x plus 9. And those are difference of squares. Can you have them, a lot of those? They're not as common as the simple. Okay, so common factor. Remember the crown I made? If you can common factor, you must common factor. It's always your first step. So our first step is always saying, oh, is there something we can divide all our terms by? So in this case, we can divide everyone by 2. Where does that 2 go? It goes out front. So what's left inside? Well, let's divide. 2x squared divided by x squared, or divided by 2. X squared minus 25 divided by 2. 25. Hey, is that something special? Yeah? It's a difference of squares. So that becomes x from x minus 5x plus 5. So notice how initially they weren't perfect squares. But after we common factored, something just suddenly bloomed. And they came out. So when factoring a quadratic expression, always take out a common factor. GCF is always your first step. Okay? GCF first. Greatest common factor. Greatest common factor. Okay, so write each quadratic in factored form. So our first step, is there a number we can divide into 5 and 20? 5. So where is that 5 going to go? Well, we actually put it in front when we factored it out. And then we divide each of them by that. You could put y. It's good to get used to functional notation, but I know it's, yeah. So 5x squared divided by 5 is just x squared. And 20 divided by 5, 4. Can we factor this guy further? Yeah. What do we call him? Difference of squares. We can take the square root of both. So it becomes x minus 2x plus 2. Do you notice this form? Factored form. Right? That would be our a value and then our x-intercepts. And we're going to use that later on. Okay, next guy. Is there something we could divide all 3 of those by? 2. So if I divide them each by, so that 2 is going to go out front. Let's divide everybody by 2. What's left over? X squared plus 8x plus 15. Woo, what kind of guy is that? Is that simple? Be simple trinomial. So how would you factor a simple trinomial? 2 numbers that add to the middle, multiply 2. So multiplies to 15, multiplies to the last, adds to the middle. Okay, what are our 2 numbers? How can we multiply to 15? 1, 15, 2 and, nope, 3 and 5. Which one adds to 8? 3 and 5. So notice how if they're both positives, then your 2 numbers are going to be positive. So we would write this. Do you still write the 2 in front? Yep. And then we add 2 sets of brackets. The first is x plus 3 and x plus 5. There you go. Nope. That's as far as it goes. Only if we have an x squared do you want to break it down further. So now that everyone's just an x, we're happy. Okay, 16 and 64. Is there something we can divide both those by? 8? How about 16? Does 16 go into 64? Give it a shot. It does. So 16 is going out front. We're left with x squared minus 4. See, if we divided both of them by 4, then we'd have 4x squared minus 8 inside, and we could still reduce that, or minus 16. So you always want to break it down as far as you can. So it's the largest number that would go into both. Okay, what's that? That's an x squared. We can break them down more. I heard it said. How would you write that now? X minus 2x plus 2. Okay, next guy. Here's a little tip. We never want to have a negative with our x squared. So what number can we divide what number will go into 3, 6, and 9? 3. But we're also going to bring out the negative here. So we're going to actually factor out the negative 3 as well. Negative 3. What's left inside? Positive x squared. What's a 6x divided by negative 3? Positive or negative 2x? Negative, because we had a positive divided by a negative, which is a negative. And then positive 9 divided by negative 3, minus 3. So we have an x squared there. We want to break it down more. 2 numbers that multiply to negative 3 and add to negative 2. So if you're multiplying to negative, whenever we multiply to our negative, what are our signs going to be? 1 positive, 1 negative. So with 3, it's either going to be negative 1 positive 3 or 1 and negative 3? Which one adds to negative 2? 1 and negative 3. So that becomes x plus 1 times x minus 3. Good work. Okay, that is all we're going to cover for today. So all of 1 to 6. Okay, all of 1 to 6 is the first assignment. At this time, you may work on your homework from the last unit, or if you want to first get this assignment done, you can, and then move on to your last unit. It's up to you. Okay?